Hello, calculus fans. All right, let's try another example. We'll do the integral from 0 to 2 of x squared times the square root of x plus 7 dx. We're going to do this with a substitution. We'll let u be equal to x plus 7. That's our inside function. That's pretty typical. Du is equal to dx. Well, that's nice. We don't even have to fix anything up. We do need to figure out what x is, because one of the pieces in here is this x squared. And we have to transform that into u. And so the way to do it is to solve for x. We'll take our substitution equation and solve for x. And so we'll see that x is equal to u minus 7. Right? If we subtract 7 from both sides, we'll see what x is. And that's going to enable us to substitute this portion here into u. We also need to change our limits. When x is equal to 0, u is equal to 7. Right? We're just plugging in the 0 into this here. And same for the upper limit. U of 2 is equal to 9. All right, we've got all the pieces we need now in order to be able to make our substitution. So when we substitute, we take our original integral, the limits get changed from 0 to 2 into 7 to 9. The x squared, remember that we solved for x. X was equal to u minus 7, so x squared turns into u minus 7 squared. And then finally, square root of x plus 7 turns into square root of u. Maybe I shouldn't say finally, because there's one other piece. What's the other piece? Right here, dx gets changed into du. Okay, now we have a new integral. We don't need to mess around with the integral in x anymore. We're just going to deal with the u. Okay, so I'm multiplying everything out here. So the u minus 7 squared turns into u squared minus 14u plus 49. And if we rewrite the square root of u as u to the 1/2 and distribute, then we get this integral. Now it's a little long, but it's actually a pretty easy integral to do because all we have to do is apply the power rule a couple of times. Okay, that's what we're going to do. So u to the 5/2, when we anti-differentiate, we'll get 2/7 u to the 7/2. The u to the 3/2 turns into 2/5 u to the 5/2. Keep the minus 14. And then the last piece, u to the 1/2 turns into 2/3 u to the 3/2. Also keep the 49. And we're just going to plug in the 7 and the 9. We're not going to go back to the original integral. We don't need to. The substitution rule tells us that we change the limits of integration and we have a new integral that we deal with. We don't go back to the original variable. All right, so if we just plug everything in, we get this pretty serious mess here. I'm actually not going to bother to simplify this. If you needed to, you might be able to simplify it, but I'm going to leave it like this. Notice that I'm writing things in exact value. All right, so I haven't discussed this yet. Exact value means that it's not a decimal approximation. You don't want to put this into your calculator and report a decimal approximation. You can always take this particular exact value and convert it into a decimal approximation, but you can't go in the other direction, which is why in this class we are always going to report exact values unless a problem specifies otherwise. So this is going to be our answer. Okay, that's all for now.